Hello students, today we are going to see the part or the remaining part from the chapter number 5 related with the virtual class and the abstract based classes. So in this video I'm going to cover the remaining part from the chapter number 5. So let's start. So our first point is what is mean by the virtual based class. So first as you can see in the diagram, so first what is the need for the virtual base class that we will see. So just see the diagram here. Consider the situation given in the figure where we have one class as a. So this class A is inherited by two other classes, that is nothing but the class B and class C, right? So B and C, these two classes are derived from class A. Both B and C are inherited into another new class, that is nothing but the class D. That is nothing but class D is generated from two base classes, that is class B and class C. So as we can see from the figure that the data members or the functions of class A are inherited twice to the class D. So let me clear you. So what I have said that as you can see that the data members or the functions of a class A. So whatever data members we have declared in class A or the functions we have declared in class A, that are get duplicated in the class D. Now how they are get duplicated? So let's see. So the data members and the functions, they first come to the class B and C, as B and C are child class of the class A. So automatically these data members and the functions will get inherited into class B and C, and from B and C we have generated class D. So by default all the members or the functions of class B and C will get inherited into D. So as I have told you that class D will have duplicate data members or the functions from class A, that is nothing but one through class B and second through class C. So whenever any data member or function of class A is accessed by an object of a class D, the compiler will get confused or ambiguity arises as to which data or function member would be called by the compiler. Okay, so the compiler is get confused that which function or which data should be used. That is nothing but the one which is inherited through B or another inherited through C, and due to this compiler throws an error. So how to solve this problem? So to resolve this ambiguity, we have a solution that when class A is inherited in both class B and C, it is declared as a virtual base class by placing a keyword virtual. So what we have to do is that whenever a class A is inherited by both the classes B and C, that is B and C are the child classes of A. So what we have to do is that we have to just make the class B and class C as a virtual classes. So whenever virtual keyword we are using, at that time only one copy of data or function member will be copied to class C and B, and class A will become a virtual base class. Okay, so whenever we will make class B and class C as a virtual, so only one copy of a data member will be get copied to the class D, and class A will become as your virtual base class. So that is the actual need for making the class as a virtual base class. Okay, so I hope you get understood what is the need for the virtual base classes. Is that just I have given you one example that I have one class as a class A, from that I have generated two more classes as a B and C. So B and C are inherited from class A, so it will have all the data members and functions from class A. So that from B and C again I have generated one more class as a class D, and as it is generated from B and C, class D will have again the members from B, C as well as A. So D will have a duplication of data and the functions, due to which compiler will get confused of which function should be called. And to avoid this ambiguity, we have to make the class as a virtual class, and here we will make a class B and C as a virtual. So by default class A will become as a virtual base class, and due to this the duplication of data and the function will get avoided in class D. So that is the need for the virtual base class. This is the syntax for the making virtual class as a class B. Then we have to put as a virtual, then public A. So class B is a new class and it is inherited from a class A, and public is access specifier, you are aware about it, and virtual is a keyword. The another syntax is also valid, that is class C public virtual A, means we can use the virtual keyword before public or the before access specifier or after access specifier, both are valid. Okay, so whenever a base class is specified in this example, so whenever a base class, that is nothing but the class A, is specified as a virtual base class, it can act as an indirect base more than once without duplication of its data members, means it avoids the duplication of a data members. A single copy of all its data members or the functions is shared by all the base classes that use the virtual base class. Okay, so by using or by making the base class as a virtual base class, we can avoid the duplication of a data. So this is the syntax for the using or the for the making of the virtual base class. Okay, so let's see one example of it, how to make an how to use an virtual base class. So we'll do one program for it so that you can get understood. Okay, so hash include iostream.h, then hash include conio.h, then again I'll declare one class as a class A. In that simple program we are making public, then I will make one method public A function, that is the function from A, and I will just display one message as a C out in function A. Okay, first we will do the program without virtual so that you can understood how to use it. Then again I will take one more class as a class B, and in that make public A. Okay, again in public I will take void B function C out in function B. Okay, simple message we have taken and complete the class again. So class A, then B, whatever diagram we have seen, let's make an program for it so that it will be easy to understood. So again according to diagram, class C was there and it was inherited again from public A. Okay, so again I will make one more method public void C function C out in function C. Okay, so here we have completed our third class. Okay, then again class class D, and then it is inherited from two classes, public B, comma public C. Okay, as per the diagram that we have made. Okay, so enter again. I will take one more method, public void D function. Okay, in that we will again print one message, in function D. Okay, then close the curly bracket, close the class. Okay, then main method, integer main, clear the screen. Then first what we will do, we'll make an object of a class D1. Then with the help of D1 dot methods are, we will call all the methods a function, then D1 dot B function, then D1 dot C function, D1 dot D function. So all the methods we will call first get ch, then return 0. Okay, so the simple program we have made. Now see the error. What is the error? Is that member is ambiguous a function, a function. That is nothing but compiler is get confused upon which function should get called, because all are copied or these are duplicated in class D from class B as well as class C. Okay, so to avoid this condition, what we have to make, or we have to make class B as an public, or as an virtual class. Okay, so what we will do, we will make this public, then virtual A, and again here also we need to make it as a virtual. Okay, so just we will see, compile, so the error has gone, so it will point exactly to the function and the duplications will get avoided. So that is the use of the virtual. So you can see in function A, B, C and D, so all the functions are get executed. So that is the use or reason why we are making the class as a virtual class. Okay, so what we have done, just see, I have made first class A. We have taken one class as a in that one function is taken. So initially we have not used this virtual keyword. So again some functions I have taken. Class B, it is inherited from class A. Class C is also inherited from class A. Then class D, it is inherited from class B and C. So that is the case, and due to which the compiler is get confused because of the duplication of the data or duplication of the functions. To avoid this, what we have done, we have made a class A as a virtual base class. So obviously whenever we are using the class A, we have to just make it as a virtual, due to which this duplication of a data get avoided. So that is the use and the way of making the base class as a virtual class. Okay, so let's see the next point. Next point. So next point is the early binding and late binding. So this actually in our syllabus only late binding is given. So I have taken both the points so that you can get understood what is what are the both the concepts. So first, early binding. In the early binding, the compiler matches the function call with the correct function definition at a compile time. Okay, so in early binding, compiler matches the function call with the correct function definition at a compile time. So it is also known as a static binding or compile time binding. By default, the compiler goes to the function definition which has been called during the compile time. So all the function calls you have studied till now, these are due to the early binding only. Means whatever uh, functions we are calling with the help of the object, that all are done at the compile time only, and that's why these are called as an early binding. So we have already studied the function overriding concept. So I hope you understood, or you still remember what is function overriding. So in which the in function overriding, what we are doing, the base and derived class have the same function name. Hmm? So it is the function overriding concept we have used in inheritance concept, where in the base class as well as the derived class have the functions, and these functions are having the same name, same parameters and return type also. So that concept is called as an function overriding. So in that also, in function overriding also, the early binding is done. So with the help of the same concept, that is function overriding, let's see, or let's understood the example of the early binding first. So we will do one example or one program here. So in the same program, I'll make some changes, or we'll do new file. Okay, so hash include iostream.h new.h. Okay, let's take an one class as a class A. In that public, I'll make one method void show. Okay, in that print one message as a C out in class A. Complete the class. Again, I will make one more class as a class B, which is derived from class public A. Okay, in that also, again in public area, what we will do, we will make again the same method as a void show. So this is called as a function overriding, because void show method is present in parent class as well as the child class, that is class A as well as class B. Okay, so it is nothing but the function overriding. So in class B, so that message we have printed over here. Okay, in class B. Now let's write an main method, integer main. Okay, then clear screen. Now here what we have to do, we will use a simple pointer concept. So we will first create a pointer of the base class. So our base class is A, and for this I will create a pointer P. Then we will create an object of a derived class as a, we are having B and B1. Okay, B1 is an object of a derived class. Now what we can do, we will store the address of the base class object, that is B1, in pointer variable. Okay, so P is equals to and B1, so that we will do. After that, due to this, that is storing the uh, object into pointer, the pointer P start started referencing to the object b1 of the base class. With the help of this, what we have done is we have just we have just done that p is equals to and b1. With the help of this, the object b1 is assigned to the p, that is nothing but p has pointing to the class b, or the base class or the object of a class b. Okay, now what we have to do is that with the help of this pointer we will call the method as a void show. The show method is available in both class A or the parent class as well as the child class also. So which method it will call? So it will just call the method of a parent class, because the method is being pointed by with the help of the pointer, and we have created the pointer for a parent class, so it will point to the parent class only. Okay, so return 0. So this show method is being called from the parent class only. Okay, so we will get an output as a in class A. So let's check. Okay, in class A. So this is the output for this program, and it is called as an early binding. Okay, so that we have done. Now next concept is the what is mean by the late binding. Okay, so late binding, so in the early binding, in the case of the late binding, the compiler matches the function call with the correct function definition at the runtime. Same thing is happening as like a early binding, only difference is that in case of the late binding, the compiler matches the function call with the correct function definition at its runtime, not its compile time. It is also called as a dynamic binding or runtime binding. In late binding, the compiler identifies the type of the object at the runtime and then matches the function call with the correct function definition. By default, early binding takes place. So, if by any means we tell the compiler to perform the late binding, then the problem in the previous example can be solved. This can be achieved by declaring the virtual function. So by default, compiler is executing the early binding only. Okay, so if we want to do the or if we want to make the compiler late binding, then we have to use the concept of a virtual function. Okay, so let's see the same example for the late binding. So what we will do, we will use the same example so that you can get understood what is mean by the late binding. So same example, for this example we are getting the output as a in class B. Now we have to do the late binding, so for which we will make we will take an help of a virtual keyword over here. So what we will do, we will make it as a virtual void show. Okay, so what we have done here, the function show of the base class we have made as a virtual. So as it is made as a virtual, the compiler performs the late binding on this function. Okay, so void show we have made it as a virtual. So whenever compiler encounters the virtual keyword, so the compiler will do the late binding for this void show, and it will now the function call will be matched to the function definition at the runtime. And since the compiler now identifies the pointer p is referring to the object b1, so we have made the same program. Okay, pointer p is pointing to the object b1 of the derived class, it will call show function of a derived class only. Okay, so what we have done, virtual we have made as a parent function. And now whenever compiler finds this virtual keyword, what it will do, it will make this function it as a late binding. And as we have made p is equals to and b1, and b1 is an object of a class b, so this function p show, it will execute the function from a derived class only, and this concept is called as an late binding. Okay, so now we will get an output as a in class b. Okay, so you can see, so this is called as an late binding. Okay, so I hope you understood. If we remove this virtual keyword, then compiler is doing early binding. Okay, so in class a we are getting, and when we are making this function as a virtual function, at that time compiler make this function available as a late compiling, and with the help of this p show, it will point exactly the show function for which we have made the object, and we have made the object for a derived class. So for this case we are getting the output from the derived class only, and it is called as an late binding. So this is late binding. Next point is nothing but pure virtual function. A pure virtual function is a function which is declared in the base class but not defined in the base class. Okay, so what is the meaning of a pure virtual function is, that is, it is a function which is only declared in the base class but not defined in the base class. Generally what happens, whenever we declare any function in a class, we define that function with the same class reference, but in case of the pure virtual function, the function is only declared in the base class without any code, and it is redefined in and declared in a derived classes. Okay, so pure virtual function, it is only declared in a base class, but the code or the definition of that function is not written in a base class. Okay, so the pure virtual function is designed for inheritance purpose only. Okay, so obviously base class, derived class, these concepts are from the inheritance only. So this pure virtual function is designed only for the inheritance purpose. The pure virtual functions are declared in the base class and again redefined in its derived class only. Okay, so the whenever pure virtual function it is declared in the base class, its definition is written in a in its derived class only. It is also called as do nothing function, because in base class we are just declaring the function without doing anything. So that's why this pure virtual function is also called as an do nothing function. The syntax for the pure virtual function is virtual keyword, then return type, and the function name is equals to 0. So that is the syntax for the pure virtual function. So for example, virtual keyword, then return type is void, then display is equals to 0. So that is pure virtual function. Next, abstract class. Pure virtual function and abstract class, they both are related with the each other. Okay, how? So a class which contains pure virtual function in it is called as an abstract base class. Okay, the class which contains a pure virtual function in it, then such class is called as an abstract class. Abstract base class never allows to create object of it. Okay, so when if there is a class, that is class a, and in that class suppose I have declared one function as a pure virtual function, and whenever I declare the function as a pure virtual function, that particular class will become as an abstract class, and if the class becomes an abstract class, at that time that class never allows to create object of it. So that is the restriction for an abstract base class. Abstract base classes are used to create a base class pointer at runtime to get dynamic polymorphism. So these base classes are used to create base class pointer at runtime to get a dynamic polymorphism. Okay, so let's see one example that how what is mean by the abstract class and pure virtual function. So we will do one program for it. So let's see. Okay, so first iostream.h hash include conio.h. Okay, then we will uh, we will do the simple program to find the area of an triangle and area of an rectangle. Okay, so simple program will do. First create one class as a class base. In that class I will take some variable in a protected, because I want to use these variables in its derived class also. So protected, and suppose I'll take two variables as a float first d and d1. Okay, to take the data for calculating the area of a rectangle and the triangle. Okay, then I will take one method over here to take an data public. Okay, suppose void get data is the method. Now what I will do in this data method, I will do only c in d and d1. The reason is that I want to take an input from the user for both, for calculating both area of an rectangle as well as triangle. So commonly I will take the input from the user in a main only. So here I am just using c in, not c out, and after that now I will declare a pure virtual function over here. Okay, the reason, because we are declaring the pure virtual function in base class only. Okay, so that's why I will declare the virtual function here. So first virtual, then return type, suppose I will take float because we have to calculate the area and area. Okay, so area is equals to 0. So this will be my pure virtual function, pure virtual function. Okay, now this class base contains this pure this virtual function or the pure virtual function. That's why this class base becomes an abstract base class. Okay, as this class base contains the pure virtual function, this class base will become now as a abstract base class. So this is only declaration of an pure virtual function. So as I already told, we are just declaring the virtual function in the base class. We have to define, or we have to write code for the pure virtual function in its derived class only. Okay, so now suppose I will make one derived class as a class triangle. Okay, which is inherited from base class. Okay, in this what we will do, in public we will calculate the area of a triangle in this function. So what we have to do now, we can write the code, or we can write the definition for this pure virtual function. So virtual, then float area. Okay, now the that we will do, so it will return the area as a, so the what we, how we calculate 0.5 5 f because it is float, then d into d1. So that is the formula for calculating the area of a triangle. Okay, so this will return the area of an triangle. So class triangle is over. Similarly, I will make one more class as a class rectangle, and again same public base. Okay, so in that also what we will do, public, again virtual float area, same function, virtual function we are using, only difference is what it will return now the area of an rectangle. The formula is d into d1. Okay, so complete the function, complete the class. Now we will take main, integer main. Then what we will do first, clear screen. Okay, then we will create, now we have to create the object for both rectangle as well as the triangle, because if we create only one object, then it will not take the exact values or it will not return the exact area. So that's why for this example we are creating the two objects for triangle. Object of a triangle, triangle T1. Okay, then T1, then with the help of T1 we can access the method, or we can calculate the area of a triangle only. So before calculating, what we have to do, we have to take a input from the user, because in get data I have just taken as a in C in. Okay, so before this I will print one message over here as a C out, then enter base and height to calculate the area of an triangle. Okay, then C in already there, so what we will do, we will just call this method as a T1 dot get data. Okay, after that we will just print the area over here. See out, area of triangle is T1 dot area, so it will print the area of an triangle. Okay, now we have to also show the area of an rectangle. So what we will do, first create an object of an rectangle R1 I am creating, then again same C out, enter length and width. Okay, then again R1 dot get data, R1 dot get data I am calling here, then again C out, area of rectangle is, okay, R1 dot area, so it will calculate or it will return the area of an rectangle. Okay, So get ch, then return 0. Okay, so that is the program for pure virtual function. So just see once again. So what we have done, so we have taken one class here, class base. In that I have taken two variables as a d and d1. Then I have declared one method in a public, that is void get data, where I have scanned d and d1. D and d1 will be the data which is required for calculating the area of triangle and rectangle. Okay, then I have declared the function as a pure virtual function. So this pure virtual function is the function we have declared as a virtual float area is equals to 0. So this is declared in a class base, that's why this class base will now become as an abstract base class. Okay, because the class which contains the pure virtual function, that we call it as an abstract base class. Okay, so class base will become as an abstract class. Now second, next we have done, we have generated one more class as a class triangle, and it is inherited from base, and in that we have written the definition of an pure virtual function, because for pure virtual function we can't write a definition in base class, we have to declare write a definition of base class in its derived class only. So class triangle is in derived class from base, so we can write the definition. So we have written the definition to calculate the area of an triangle. Similarly, we have generated one more class as a class rectangle from the base, and here also we have written the pure virtual function definition, and it will return the area of an rectangle. In main, we have created two objects to point to the area of a respective classes. So triangle T1 and rectangle R1, these are the two objects. So we have first taken the base and height from the user, then T1 dot get data will scan the base and height as a D and D1, then it will just print the area of a triangle as a T1 dot area. Then we have generated one more object of a rectangle, that is rectangle R1. Then we have taken length and width to calculate the area of an rectangle. R1 dot get data will scan D and D1 for the rectangle data, and it will print the area of an rectangle. So this is the simple program for pure virtual function. So compile, there is no error, run. Okay, so enter base and height. So I'll enter base, height is 6, so the area is 23 point something. Now enter length and width, that will be for the rectangle, so 6 and 8.9. okay, so that will be the area of an rectangle. So this is the simple program for the pure virtual function. Okay, I hope you understood this. Now, so here we have completed our fifth chapter. So in the fifth chapter we have seen the points related with the pointers and the virtual function. First we have seen the memory management operators, that is new and delete. So new and delete, new is used to allocate the memory, and delete is used to delete the allocated memory. So some syntax, some examples we have seen for the same. Then we have seen this pointer concept. This pointer is mostly used, so please try the examples on this. So in C, we this pointer is same as like a AND, which we are using in C. So in C++ we are using this pointer to know the address of a current object of a class. So this pointer is used to know the address of current object. So that is the use of this pointer. After that we have seen pointer to derived class object. We have seen the examples also. Then we have seen the virtual base class concept, why to use the virtual base classes, that examples also we have seen. This is the syntax. Then we have seen the concepts of the early binding and late binding. These are related with the how compiler compiles the functions which we are generating with the help of the object. Okay, so in earlier examples we have compiled or we have seen compiled the functions with the help of the object, but in case of the early binding and late binding we have compiled we have executed the objects with the help of the pointer concept. So same examples I have shown you for both early and late binding. Then we have seen the pure virtual function. This is also important point in this chapter, so pay attention on it. So it is very simple. So pure virtual function is always declared in a base class and its definition is always written in its derived class. So that is only you have to remember. So that is the syntax for the pure virtual function, and the class which contains the pure virtual function, that class is called as an abstract class. So there is no separate program for this abstract class. So these all points are from the chapter number 5. So here we have completed our 5th chapter. If you have any query, you can send me the message. Thank you.